This strange zip file was found in a user's downloads folder. Non-compete agreement installment sale 38907. Opening the zip file, we have a .js script. So to get started with some analysis, for safety reasons, I'm not going to be opening this up on Windows. I do want to take a look at it in Remnux, the reverse engineering and malware Linux distribution, and I've opened up my terminal here with a directory that's just the strange download and the non-compete agreement installment sales zip file. So I'm going to go ahead and unzip this. I'll go ahead and tab complete that, and it goes ahead and extracts it to a non-compete agreement installment sale.js, that very same JScript file that we were just looking at. So I'm going to take a look at this within Sublime Text, my text editor, and let's see what this thing is. Interestingly enough, it looks just like a regular online library or module or component written in JavaScript that would then be used for other online applications like websites. But interestingly enough, if I kind of keep exploring and scroll down through here, we see some weird looking code. Here's a function bitf with an argument cot3 that has more randomly named variables to do different things, all kind of strewed along and kind of just carried throughout what was originally probably genuine code, like actual legitimate code written for a library called Backbone. And we can actually do some research here. Backbone.js is, of course, a real legitimate JavaScript model. This file was trying to masquerade as version 1.41, so I'm kind of curious, hey, can we actually get that 1.41? This is, of course, the production minified and compressed rendition, but if we did the development version, we might be able to see exactly what we saw just a moment ago within Sublime Text. So here's an idea. We could honestly just kind of take this original source code, make it a original file, original backbone.js is suppose a fine name here, and with that, we could kind of compare and contrast, hey, what does one look like compared to the other side by side. We can use the diff tool to take a look at this. We could use a graphical tool like melt to see the differences. It might be meld. Let's go find out. Let me see. Is it meld? Yeah. Okay. Sudo install meld. Totally cool with installing that. That's a good one if you wanted a graphical representation of the different files here. And now that's downloaded, I can run meld with the non-compete and the original Backbone file. It says, hey, these files were really, really large. So, hey, we could try and keep highlighting it despite all those differences. But take a look on all the green interjected portions here that are not present in the right-hand original Backbone script. All the other lines, verbatim as they were, are still present, but just kind of cut up and kind of separated with malicious code with that weird obfuscated sense. So with meld identifying all the things that were present in one file and not the other, we could actually go ahead and save as or format as patch, which will give us the diff with the patch kind of file format and structure as to the lines that are present or not present in the other. This might be kind of cool because we could go and extract out and carve out all of those ones prefixed by the minus sign, or the lines that were different or not in the other original file. So let me go ahead and save this. I'll put this as differences, and I guess that's just fine as without a file extension. So if I take a look at this, this is everything that we just saw, but I want only the lines that start with this hyphen here, or the minus sign to say this is in the other left-hand side of the files that we were comparing. So let's try to see if we can cut those out. So what I'll do is I'll cat out the difference file and pipe it to grep, or I will only look with extended regular expressions, the things that start with, so the arrow, the caret symbol referring to the very start of a line, a hyphen, and then literally anything that follows it. Can I get that? There we go. Now I have all of that output that seems to have matched. And let's see, do I have clear functions at the very, very beginning of this? I know this is a lot of red. It looks pretty bloody. Here, let's just go ahead and redirect this to a bad.js or JavaScript. Can I open that up? Yeah. Okay, cool. So it looks like it has intact functions at the very, very beginning, and maybe building out all of the functionality and features that this original stager would have needed. Now I can go ahead and remove, I'm going to hit Control A to select all lines, Control Shift L in Sublime Text. I'm going to press the Home key and then just shift over with my arrow to the right to remove all of those preceding hyphens. We could very well have done that in Bash with some sweet commands, but hey, Sublime Text makes it just as easy. Now, if I turn on word wrap, we might be able to see just how egregious this thing is. Over in the right-hand scroll bar of Sublime Text, you can see a lot of nonsense, a whole lot of obfuscated data. It looks like, oh, there might even still be some comment that it extends of Backbone. Whatever. All of this looks like nonsense though. And I gotta be honest, obfuscated JavaScript sucks, especially with this amount, like this sheer caliber of how much data that we want to dig through and try to reverse. I don't exactly want to do that by hand. I'll be the first to admit. So with this carved out, I think I'll go ahead and honestly bring this back over to Windows and see if I can do some dynamic analysis to see what the heck this thing does when it's ran, when it's executed and detonated on a machine. So I've got this file now present inside of the Flare VM, and I do want to go ahead and disconnect the network adapter just in case there's any oddities to this thing. So I'll go ahead over to VM, removable devices, and just turn off the network adapter, hey, just in case. And then I gotta be honest, let's set this thing up to watch it and monitor it. I'm gonna keep it simple. I'll open up ProcWatch to monitor for new processes. I'll go ahead and open up Process Explorer so that I can see that just as well. I'll open up ProcMon, and this isn't super advanced, but it's at least a little bit of visibility as to what's going on, where and when and how. I'll also open up the command prompt and I'll drag that down here. I'll move into the desktop, and with that, I should still see my bad.js file present, which I do. So what I will do is actually clear this list for monitoring processes in ProcWatch, and I'm going to filter with Process Monitor for the process name being cscript.exe, because I want to go ahead and use cscript to actually execute this. I'm not going to double click it on the desktop because that would fire off wscript or one of the Windows like graphical user representations for running those JScript files. I could very well do this from the command line. I'll keep filter on for Process Monitor, make sure it's listening and watching, and then I'll try and run my cscript.exe on my bad.js file. Now I want to keep an eye on Process Explorer, ProcMon, and ProcWatch, and let's see, when I fire this thing off, what is it going to do? So it ends up invoking, of course, cscript. Nothing else seems to follow it. It looks like it's still running, which is interesting. And there are a whole lot of results coming inside of Process Monitor. A whole lot of opening registry keys, a whole lot of, hey, loading DLLs, things that will need to be able to actually do stuff. But I'm curious which of these things are actually going to be left over as artifacts once the script runs or finishes, or I don't know, what does it try to do? Okay, so finally it has ended. cscript has closed, and I want to know, okay, what is actually happening here? I'm going to expand out Process Monitor to see what they've got going on, the results, the details, anything that might be interesting. But note there are about 8,000 events. So there's a whole lot to sift through here. Trust me, a whole lot of this is boilerplate and not all that interesting, but I do want to see, are there any breadcrumbs we might be able to latch onto? Here's opening the file, reading it, doing what it does, grabbing a whole lot of encryption style stuff like bcrypt, RSA. Maybe some of this data that was obfuscated was also encrypted, and that's one of the things, like, you never exactly run that backwards unless you stare at it for a long, long time. Oh, you know what? I should have ran RedShot to see what was different before and after this. I also probably should have made a snapshot. Oh, there are a lot of write files here to app data roaming npm cache construction products.log. That looks very weird. There are a lot of these. I am still scrolling. Construction products.log probably isn't normally in the npm cache. I want to go take a look at that, but I do want to go see, look at the offsets here. It's just keep writing crap. What is it doing? Whoa. Oh, there's a new one here. Interact in design? Presumably, okay, making sure if it does or doesn't exist. But then they grab the information, set the rename information. What is the properties on that? Ooh, okay, so it renames what would have been our construction products to interactiondesign.js. And then they play with that for a little bit over and over again. And then the end of this just looks like regular teardown. They're also playing with scheduled tasks. Did they set any of those? I'm curious, what sort of persistence did they make? Did they make any? Do I have auto runs? Yeah, I do. Okay, cool. Okay, so some of this is just going to be normal, natural stuff that the Flare VM does. Ooh, but hey, take a look at these scheduled tasks here. Yeah, well, that one looks relatively normal. Windows Media Sharing Update Library. But electrical safety? No, that looks a little bit weird. Can I see the properties on that? File does not exist. And that's supposed to be wscript. So allegedly present in our npm cache directory. And d.exe, which is not present. Where did that one come from? That one's sketch. Also file not found. But seeing some of the task scheduling DLLs loaded within Procmon from our C script execution, and now seeing some of these electrical safety trying to run stuff, if we had that C script.exe, I wonder what it would be doing. Can I still dig into that? Can I still see what it's trying to do? Within auto runs, we can actually jump to entry, and that tries to open it within the task scheduler, but it's not present. I don't see it. Like, it's not even under, hey, Microsoft Windows or whatever. It's supposed to just be here. What if I were to go put a file there? Like, can I just copy Windows System 32? Let's do Notepad. Let's go ahead and put Notepad in that npm cache directory. That's in app data under roaming. Yep, which is where I am. Okay, npm cache. And there is our interaction design.javascript file. If I just put a notepad.exe, change that to wscript.exe. Will this thing run? Hello? Weird. You're supposed to be running Notepad. Oh, you probably don't have whatever DLL crap that you need. We could put calculator, but then it's just going to call back to something else. Like, that would be dumb. Let's try it. Here's a calc.exe, slap that fellow there. Let's rename that as our wscript.exe. Will that run? There's a little calculator. Okay, cool. So, electrical safety. Can I refresh this now? Presumably. Electrical safety, wscript, and ooh, check it out. Okay, obviously it's a fake calculator application taking the place of it, but it will try to fill that out and run our interact1.js file, which is one of those expanded like DOS prompt things. I think that's it. Let me go to that directory and see if I could show you that. Whatever. I think I should do it with dir because that way it'll fill and kind of auto expand that file. And there it is. There's our interaction design.js. So now I want to open this thing up. All right. So let's open with Sublime Text. How big is this file? Oh my goodness. 40 megabytes? That's going to take a long time. All right. You do use Sublime Text. I'll be here. Oh my gosh. Is it almost done? Looks like it's almost done. Oh, okay. Can I even interact with this thing? Sublime Text choking. I want word wrap. Okay, here we go. Let's see. Oh my gosh. Wait, what the heck is that? What is way down here? What is all this? This is not JavaScript code. Is this a giant comment? This is just random letters. This is not code. It ends with a semicolon. Okay, at the very, very top, there is stuff. And this will execute. That'll detonate. But all of this nonsense? No. Well, okay, so it's at the very, very end. So even if it errors, everything else is already executed. So it's at the end of the code segment here, but oh God, Sublime Text is dying. Okay, so all of this is nonsense, and we can kill this. And that's like what, 90% of the file, if not 98% of the file? Like, this is the only portion I care about. So I wonder if I can just kind of cut that last bit. So this is where it starts. SRL is where all the nonsense random letters begin. Can I just chop that off? Sublime Text gonna choke on it. Okay, so let me control end. Oh no. All the way to the end. And delete. Okay, now it's gone. Right? I can save this, and now I have that. But can I beautify this? Can I beautify JavaScript, please? There is a certain amount of sketchiness in like just putting a piece of malware or like obfuscated bad code into a beautifier that is online. But I'm going to be assuming that it is written in JavaScript. I hope so. I don't have internet. Duh. All right, so let me just slap it in here, beautify that code. And there we go. Now we have some things. Save this as, I'll put it on my desktop here again. So like here's cleaned stage2.js. Okay, so this is the exact same sort of like manipulated, obfuscated, weird, random variable names and letters and just random junk that we started with in our first layer of the backbone.js. But I'm curious what this will do now. So, hey, we'll go back to some more of that dynamic analysis if we're just trusting ourselves to run it. We could go through and say, hey, here's the source of contact. Here's first touch is when we run the bright P4 function. If you wanted to trace it back between what arguments are passed to it, what would be literally and Steam 0 tend to do, but that's going to take a lot of time. And I just want to see this thing explode. But before we go any further, please let me include a quick shout out and some love to today's sponsor. If you're anything like me, you love malware. And you love hacking. You love red teaming and penetration testing and all the super cool stuff that you do with adversarial emulation. So what if you put those two together? What if you wrote and developed your own custom malware for red teaming? Well, you can learn how with some of the incredible training from the Sector 7 Institute. Now, I don't have to sing the praises for Sector 7 because you probably already know just how fantastic their material is. But if you aren't familiar, Sector 7 is all about information security research, focusing on developing and refining both new and existing offensive techniques and tradecraft. With Sector 7, you learn how to be an expert red teamer, how to build a team, and how to develop your own in-house tooling. Learn the ropes with their Red Team Operator courses, from Windows persistence, Windows privilege escalation, defense evasion, and of course, malware development. Learn how to hide your payloads in memory, in the corners and crevices of the NTFS file system and registry, create global hooks, call APIs and remote processes via RPC, perform process injection, operate with stealth, and craft userland rootkits, and so much more. Sector 7 sets the bar for red teaming training in the industry, and I'm a huge fan of all the great work that they do. And with that, I am super excited to partner with them to offer 20% off of their Malware Development Essentials course. Get started learning top-class red teaming and malware development with Sector 7 with my link below in the video description. Huge thanks to Sector 7 for sponsoring this video. So let's get back to running our Procmon, and let's get back to having Proc Watch and Proc Explorer all open. And I neglected to run like Red Shot or even TCP view. Granted, I don't have internet connectivity because I removed the network adapter, but it might still be worth trying to see what pops up and opens, or at least attempts to, right? I'll bring that over Process Monitor, actually. Well, I want all of these, I got to admit. I need more screen space. And let's bring TCP view there. Okay, so I can go ahead and slap the Red Shot on the desktop just as well. And let's go ahead and get our commander up and running. Let's bring this down to the bottom left again. I'll change directory to my desktop. Will commander know how to handle that? No. How about user profile? Our batch variable is going to work? Yeah, okay, cool. Let's get to desktop. And now I have my clean stage2.javascript file. Let's take our first shot. Okay, I think we are looking good. Let's try and take the first shot of the registry. Okay, done. A lot of keys, a lot of values. And with that, let's fire the gun here. So we want to run cscript on our cleaned stage 2. And let's see what happens. Firing it up. Cscript is cruising. I forgot. I forgot to start filtering with Procmon. No! Well, at least it was cscript. I can control C before, stuff started to happen. I'm really bad at this, guys. I'm really bad. Okay, start filtering on cscript. Let's stop and start. There we go. And let's fire the gun. Okay, cscript is now running. We see it started. And I see no outbound connections. Not that any are going to be able to try to anyway. It is going to do that. Run and process. Another hanging at about 1,834 events. Probably all the startup. Oh, there we go. Whoa. Something happening. What was that? What was that? What was that? Did you see that? Where did this PowerShell come from? Let me check Proc Watch. Oh, it tried to run PowerShell. It did. It did run PowerShell. And this is where we left off in Procmon. So let's go see what it did. What the what? Reg open key wscript.shell with random case. Looks like a little SpongeBob meme. Lot of shenanigans. Check it out. Hey, create file desktop PowerShell, name not found, PowerShell yet again. Okay, so it goes through the path trying to find and run PowerShell. So it's literally going to detonate PowerShell. There it is. Yeah. Opens it. What is this registry key? Oh, I should red shot. Before I go click around again. This meme case is obviously like a smoking gun. And then it dies. And then it kills itself. cscript just exits. But I want to know what's going on with PowerShell right now. That PowerShell process is still running. Okay, that's done. Can I compare these now? See what changes have been made in the registry, the best it can. This PowerShell's the weird, sketchy PowerShell. Can I get any info on that? Whoa, okay, the command line doesn't give me anything new. It's not taking in any arguments or doing anything. It's probably just executing something. Did you see the csc.exe that ran though? Like it was a child process for a moment. Let's see what .NET assemblies this thing might have pulled in. Is there anything weird or random? Yeah, there's that guy. nmouse05wh. Can I get some more details on that? It's just loaded right away. Like I'm sure it's some inline C#. Anyway, it's still running. Keys deleted 0, keys added 1, values added, values modified. Okay, so we got some stuff to look at. Some of these virtual desktop things, nothing all that cool though. Whoa. What is being set for this user assist? Randomness here. RKR CEBP64. So randomness. All right, we can go down that road a little bit later if we wanted to. If this thing had internet, I want to know what it would do. Because PowerShell is still going. Well, what we might be able to do to get a little bit more visibility as to what's happening with PowerShell is honestly just turn on PowerShell transcription logging. And I think that actually might even already be on because of Flare. Do I have PowerShell transcripts? I do. Okay, so for today, when this thing ran, that would have been a little bit ago, 356, right? So what gets started here? Yeah, here's our host application, weird wonky PowerShell meme case. And what does this thing do? Loads up the profile, outstring errors with some stuff. Oh, look at this, look at this, look at this. Here's some of the randomness. I want to grab that. Get response 0, get response 0, get response 0. Okay, it's trying to call out to something. Remote name could not be resolved. And all of these, look at that. Oh my gosh. Are these like different command and control frameworks it's trying to reach out? Dude, let's pull apart that PowerShell. Let me see that super quick. All right, ran PowerShell.ps1. All right, cool. Let's do a word wrap crap. And we've got to be able to beautify this. There is no, that I know of, like good PowerShell deobfuscator. So let me just try to cruise through this by hand here. Okay, I think I have it basically cleaned up here. We've got this function IGV kook, which is seemingly the main function passed in with an argument. There is a variable declared with a seemingly random string of hex values, an innermost function scwy that ends up writing a compressed gzip into memory. And oh man, I want that. I want to know what that is and how that's doing it. Especially because it looks like it's cut up. It joins together some pieces here and it slaps that into memory. Okay, and base 64 is in the mix just as well. But what is it pulling here? Hang on. This is, I didn't finish. There's a for loop where we get, it compresses the data that you give to it. And it's going to end up grabbing environment data, names, and OSWMI portions to get the operating system name and all. GPS is going to be get processes, I believe, to see what processes are running, to see, which active processes are open, or see what's running and displayed on your desktop with the main window title. You could like run that and validate that, along with namespace 0, which is all the items on your desktop. And we could see that. Like here, I'll show you these super duper quick. Fire up PowerShell, slap that in, desktop. You want to look through the items on that? Hey, you got it, my friend. You take the reins. Grab that, pull it out. You'll be able to see here are all the files, here are all the folders, here's everything that is on your desktop at the moment. And it looks like they're taking that data, bundling it up into a base 64 encoded gzip object, and then tries to get where there are free drives, and then, okay, yeah, does some callbacks. Like creates the TLS boilerplate to be able to create a new web request with a fake boilerplate user agent. Cookies, that look like it's grabbing each of these. Yeah, all those pieces of data that it just exfiltrated, those variables that we see being set, or all those things that we just got collected, are now going to be exfiltrated via a cookie. And that is going to use their victim ID, presumably what it looks like as to, hey, what target is this and what information have we gotten from there? And then if we have a response, like if we can pull back the response from the connection here, after we go ahead and send this, if we read to the end, splitting on the victim ID, if it provides some info, like if there are 3 counts or whatever trigger that it might need, it'll go ahead and IEX or invoke expression to run and detonate that. So it can do some command and control. It's like simple PowerShell command and control. Wow. Oh, so that, did we see an add type? Or we saw CSC get ran, but I never saw an add type. How did they... I thought I saw CSC that got ran, but maybe that's just regular PowerShell doing its thing. I don't know. It didn't show it in proc watch. But the coolest part here is this little while loop that says, hey, run that big old function for all of these potentially online, maybe available different command and control servers. And all of these are xmlrpc.php. It'll just grab a random one and then try again in 20 seconds if it failed. Try catch, do nothing if it fails, but keep cruising. With that, I think the analysis is done, but there is a looming question as to, okay, what the heck were we just looking at? If we bundled that all down to eventually just like a weird PowerShell implant for like some cutesy command and control, what about all those techniques in tradecraft and everything that might help us identify what sort of threat actor or malware family really was this? Some folks might have already caught on. This, presumably, at least it looks like Gootloader. Gootloader is kind of a recent new threat in the spotlight. However, it has been around for a couple of years, but it's seeing some peculiar stuff and actually got a Mandiant article out about it just last month in January. The Affection Chains is chatting about all the same sort of stuff that we have done. It is everything that's going to download a malicious zip archive, stored in the downloads, includes a JScript file ran with wscript.exe or cscript if we're doing it manually from the command line, but double-clicking on it will, as I mentioned, trigger wscript. It does try to reach out to some of those domains that we saw. I don't know if it's just 3 hard-coded ones. We saw a good many. And I have not yet seen all of those registry changes like phone launch or beacon that are put in here based off of their usernames. At least in the sample that we were playing with, we didn't see those changes in the registry. However, if it says it's downloading these payloads, we had internet off. We could turn this thing on if we really wanted to, but hey, that would make a little bit more of a mess. Even when I ran this in an online sandbox, and let me add a note here, it is usually discouraged to run things in an online sandbox just because you don't know, hey, what information, what thing it might do, what potentially identifiable information, whether it's for customers, clients, yada, 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 that you just don't want in the mix. So it's sort of bad practice to just give it away to that external thing. When you get to do it and play with it locally, you can, but you might not have all the bells and whistles that a nice online sandbox might have. So of course, hey, we could turn on the internet, but then I just don't know if I want to infect my virtual machine. I can roll back to snapshot if we want to, but whatever, I digress. They have also seen tradecraft that ends up building out a Cobalt Strike beacon. However, I'll admit, I haven't seen that. Ours was just like a weird command and control with PowerShell, but maybe I'm out of the loop or I didn't track down all the odds and ends of it. Really neat thing though, exactly what we were seeing, wscript ends up creating an inflated file with a .log extension. That was our like construction products.log or whatever, to random directory hard-coded file name, and ends up obfuscating JScript followed by a padding of random characters to increase the file size. That 40 megabyte file is intentionally put that way so that antivirus vendors or whatever products and security mechanisms might just choke on it, like Sublime Text was when I tried to open it. Log is renamed, ends up creating a scheduled task that executed, as we saw. There it is. WScript and CScript launch a PowerShell process that reaches out to 10 hard-coded domains. Okay, so that is what we saw. And exactly as we saw it, grabbing environment variables, Windows OS version file names, running processes, gzip compressed, base64 encoded, and then sent to the control C2 server in the cookie. Cruising through this, because again, this is just a recap on everything that you've seen. The obfuscated stuff, as we were just taking a look at, again, even looks like Gootloader. Randomly named variables, lots of backslashes and single quotes and things that it just slaps together here. And another recent change that we were even privy to was our backbone.js or genuine JavaScript file, like a JavaScript library. Looks like they had ones that they'd seen through like a Trojanized or another representation of like a jQuery library. And here they go into exactly that. Several legitimate JavaScript libraries, chroma _, and ours was Backbone. They do list a whole lot of indicators of compromise or other things that we were just seeing and tracking. But hey, all in all, really great article and write-up from Mandiant. Huge kudos and hats off to you all for that. I am curious if we would have been able to see those phone launch or phone launch beacon, fax, phone, whatever things, because those are .NET assemblies, and you can see they cracked them open with dnspy. And since we saw that csc.exe, the C# compiler execute, I wonder if it was trying to do that, but we just didn't have it pulled down. So I'm curious if we would have been able to find those. Another good threat intel blog and article on this from our good friends over at Red Canary. I see some familiar faces on this. Hey, great to see you doing great work. And again, this is in May of 2022, last modified in November. So some changes, and look, Gootloader is nothing new by any means. It's still one threat that's out there and around using some of those JScript, PowerShell, .NET shenanigans. They do all have the same sort of lore in the file name or even the downloadable that is starting this thing off, like financial support, broker price option, progress billing, trying to look relatively reasonable, but still evil. Here's a, hey, how do I withdraw funds, right? They were also tracking that same .NET DLL persistence and the scheduled task to run whenever the user logs in, as we saw. Granted, maybe we could have seen Cobalt Strike come through this, but again, we did not get the C2 server's response from if it were to actually connect externally online. But if I may please say, Gootloader has been running rampant for a little bit, so much so that there was even a Twitter account called Gootloader Sites that would just share a couple of those command and control sites or those XML RPC URLs that we saw, or things just hosting and serving up the original payload. Now, that account has been suspended for whatever reason online on Twitter, so that's dumb and silly, and it makes me sad because I was following that account, and I really like seeing, whoa, hey, there's a new Gootloader going around. Not that that's a good thing, but, you know, it's something to chase. With that, I've been rambling for way too long, but I hope you thought this was a fun one, a little bit exploratory, a little bit of, hey, using our own tools in our own little Flare VM or Remnux to be able to pull this apart. Nothing too crazy, nothing too fancy. We weren't digging into assembly opcodes or low-level compiled stuff, but please, please, please give some love to our sponsor, Sector 7, to be able to go dig into some of that yourself. Should be a ton of fun, and you get into more elite stuff than me, I got to admit. So, hey, still a lot of cool stuff to see the tradecraft, but I'm done yapping. I'll see you in the next video, everyone. Like, comment, subscribe. Take care.